Well, hello and welcome YouTube to Mr. Robinson's Q&A Power Hour. You didn't see that one coming, did you? I totally blindsided you with that one. Now, what is Mr. Robinson's Q&A Power Hour? Well, I'm glad you asked. Well, see, every 2 weeks, my students will submit questions to me that I will then answer for them. It's supposed to cover content that was covered in the last couple weeks, so I can answer things that they might have that either pique their interest, that they couldn't visit me for with office hours or ask during class time, especially in the distance learning format. It's a lot harder to be able to ask a teacher something, and I'm kind of requiring it of them so they can get some credit for it as well. But, so after I get that response, maybe they heard a little something more and they can go back to that specific question without having to find that section, or in case they were absent on that day, or something of that accord. So I'm here to help them with that and answer those questions, and in turn, I hope they learn something new, and we're going to be still doing some stuff in class to make that happen. This is for my Integrated Math 1 class only. Now, we just came off a unit where we were doing things with functions and sequences, so you might see some questions regarding those. Specifically arithmetic sequences as we did them. And the current unit that we are on is now referring to linear equations. So we are going to get very close to that slope-intercept form stuff in the next couple weeks. Not quite yet, but we are looking at linear equations. So you expect to see some questions there. Now, my students would receive credit for asking a question that is content related and relevant for those past couple weeks. And it should be something more of they should be able to be using their academic language on this thing. They shouldn't be asking, hey, how about question number 20? Things like that. I really want them to cover something that is in that form. I haven't read these questions yet. I made sure to just delete ones that say, I don't know. So I haven't read the questions yet, so it comes off as a surprise like last time when I got asked, who's my favorite actor that played Batman? Things like that. Every so often they ask me something like that, and I'll answer it. But I'm going to make sure that I only give credit to those who are asking the questions the way they're kind of supposed to be asked. And I'll just let them know whether or not they're getting credit or full credit on a question like that. So without further ado, guys, I'm going to go ahead and get started. I have a good slew of questions here that I hope should go pretty fast. If there are more questions, I want to go more quickly on them. And without further ado, guys, let's go ahead and get started. And our first question here says, I would like to ask about the class participation and the way we ask questions during class. Okay, one of those things. This isn't content related, so it's kind of one of those, you won't get credit for asking this question, but I'll answer. Actually, I don't know what's asking. Class participation in the way we ask questions during class. You ask a question on the power hour just like this. I don't know if that's what you're talking about. You ask questions by raising your hand, speaking up. If you guys know, we're distance learning, so it's harder to ask questions in that format sometimes. Some people don't have a microphone and such. Maybe I brought something up. I started talking to some classes about I want you guys to get more engaged and involved. So if I call on you or something, I want you to be able to hold yourself accountable and at least acknowledge me that you're there and try something even if you don't know it, because I want to assign you, class participation credit. So it's probably something like that. The way you ask questions during class. Anytime I stop for something and anytime I say any questions, I'm willing to take any questions that you want there. I'm not sure exactly what you're asking about that, but I will let you know that I do want to try and find ways to give participation credit or take away participation credit if you're not involving yourself in some way. Not by the not asking questions portion, but by not speaking up when asked to, or not working in your groups, when you're supposed to, or something like that. So I don't know what that question is. Remember, you won't really receive credit for that question because it's not a content-related question. I want content, things taught out of the book, not things taught on the syllabus, for example. All right, let's go to the next question. The next question here asks, when we do n-1, what does the n stand for? Or I'm going to guess that means f of n. So this goes back, I guess this is going back to arithmetic sequences, and more specifically the explicit rule. Now I'll let you know that although I haven't answered this question specifically in a Q&A Power Hour video, I have answered things based on explicit rules in the past. My computer thing kind of crashed here. I don't know what's going on. I have answered explicit things before in the past, so if you are having trouble with something, you can look back at one of those videos, and I might be able to have helped you on one of those. Give me 1 second here. Something's kind of crashing for me. All right, I think I'm back. Great. Okay. So n-1 and f of n. Now, the f goes outside of the parentheses in function notation like this. This is the formula for arithmetic sequence that we learned right here. Okay. F of n equals f of 1 plus d times the quantity n-1. This is the arithmetic sequence formula. Again, if you want to know why the equation means what it means, why the equation is what it is, why this formula works for what we're doing for arithmetic sequences, that is answered in my last video. I do know that for sure, so I won't be answering that part. But I will break down what all these things mean. F of 1, let's start with D. D represents the common difference. This is for an arithmetic sequence. D represents the common difference. An arithmetic sequence is a list of numbers that are separated by a common difference. If it's 3, that means the list here, this is probably the list I used last time, 2, 5, 8, 11, etc. They have a common difference of 3. I could write out this formula too if you want me to. I can use this one. N, let me go to N. N represents the position. It's the term position. All right, term position. Now, it's implied in this list, but the first number is 2. The second number is 5. The third number is 3. The third number is 8. The fourth number is 11, and the fifth number is 14. So this is when n equals 1. This is when n equals 2. This is when n equals 3. This is when n equals 4. This is when n equals 5. It's the position of it. It's implied. You might not see it, but these numbers 1, 2, 3, 4, 5 represent the position where these places are located. Now, that's what explicit formulas do. They actually use the term's position to calculate the term's value. That's what f of n is. It's the value of the nth term, whatever term that you're referring to. The value of the nth term. So if you're looking for the 7th term, you would be doing f of 7 and substitute 7 into here. Find the value of the 7th term. And 7 is actually used to help calculate your answer. So is f of 1, which is the value of the first term. Now I'm just breaking that down just so you have the idea of how n and such works. So n in itself is the position of the term. When you do f of n and you are computing for the formula, you are going to find the value of that nth term. Whenever we do f of 100, I do that quite a bit in my stuff there, we're finding the value of the 100th term. That means we're substituting 100 into here. Now, why is it 100 minus 1? I answered that in the other video. I'll save that one for you, and you can go ahead and do that one there. All right, so I hope that answers that question there. And with that one down, let's go on to the next question. And the next question that's asked is when you are doing slope and the run is going to the left, does that mean it's gonna be negative? That is a good question. If you're referring to the slope being negative, that's a kind of, I'll answer everything about that here in just a moment, but it depends on whether you're asking whether the slope's going to be negative or not, and I'll just make sure to cover both bases here. I have a little set of graph axes I'm going to pull up. So, yeah, I'll use a specific example here. So let's say we know that there's a point here that's 2, -2, and a point here that's -1, 5. And we're trying to find the slope of the line that passes through these 2 points. Now, we in class have defined a slope as a line's rise divided by its run. I've also mentioned in my class in particular that if the slope, instead of rising, if it goes down, I like to call it a fall. That way you know very specifically whether you're talking about whether it's going up or down, therefore whether that part is positive or negative. Because I like to mention run as simply going to the right. There are a lot of reasons for it. If there's any other reason to say that when I say rise, I can think up, fall, I can think down, and run doesn't really have a specificity of left or right. So let's give it right. So if you want to say run left, that's fine. Now in this particular case, if I wanted to calculate this slope, I would fall from 5 to -2. That means I would be falling 7 units. That way I would make that negative. Now when I run, and remember when I say run, I mean run right. When I run, I went from -1 to +2, so I ran 3. So the slope here, the slope is rise over run or fall over run. It's -7/3. Now the question that's asked here is, if the run is going to the left, does that mean it's going to be negative? Now I don't know if you mean slope or the run. So to answer that, let me erase the blue here and redo that. Now instead, let's go from 2, -2, and let's run to the left, and then we will rise. If I run to the left, yes, that is a negative run. Now I have ran 3 to the left, that'll be negative. But now when I rise, that will become a +7 right here. And now when you see that slope, you are going to be getting 7 over -3. Now, my question to you guys that I'll answer right after is, are these the same value? Even though they were assigned differently, are they the same value? And the answer is yes, they are. In fact, in a book or something, you would actually see the negative right in the middle, and it would be negative 7/3 like that. So it doesn't matter which way you do it, but I do recommend you mention as you run right for several different reasons. And unless someone asks me that question, I don't think I'll cover too much of that. But the run to the left is indeed negative. Does it always mean a negative slope? Depends on whether you rise or fall after that. Because what if I take this line here? What if this line instead does this? And we're going like that. And then instead we're trying to find the slope of the line that crosses through this point here and this point right here. Well, now if I run left 3 like that and I fall 3 like that, both are negative. And this slope here is negative 3 over negative 3, which is positive 1. So that overall slope wasn't negative as a result of running to the left because I also fell. I went down. And in this case, I'd much rather, of course, as you know, I'd much rather rise 3 positive and run 3 positive here. I'd always prefer my run to be positive, and then I'll decide whether I'm rising or falling. That can really help me determine whether I have a positive or negative slope and be consistent with it. It really does help for word problems, but you can see a 3 over 3 is still 1, just like that. But anyway, yeah, so I don't know which way you're asking me the question. Is it about running to the left gives you a negative run, but it doesn't always give you a negative slope. It will give you the same slope as if you ran to the right because instead you'd be falling in this case. So it's kind of like that. All right. Hope I answered that one. And with that one out of the way, guys, let's go down to the next question here. Next question asks, when finding an equation with an exponent that is multiplying something in parentheses, I assume, do we add what is in the parenthesis first, or do we solve the exponent? There's a thing flying in my face right now. You might have seen that. Shoo. When finding an equation with an exponent that is multiplying something in parentheses, do we add what's in the parentheses first, or do we solve the exponent? Here's addition. I don't know what's being asked, so I'm thinking about it. Here's addition with an exponent. Here's multiplication with an exponent. When finding... Maybe if you're talking about something on the outside, like that. Is this what's being asked? When something's multiplying by something in parentheses? Okay, I don't know what's being asked on this one. So this is where I know you tried to be specific, but you also have to be clear about it. Because you've used 3 things. You talk about multiplying, exponentiation, and addition. And I know you could have said, for example, when finding an equation with an exponent is multiplying. Maybe you're just asking about PEMDAS, just order of operations. Okay, let's say it's this. Let's say this was it that you're talking about. If this is the case, I want to add first because I want to do what's inside the parentheses first. I know that adding comes after multiplication and exponentiation, but parentheses come before the other two, so anything that's in the parentheses is done first. So first I will apply the 2 plus 3. The 4 still remains on the outside. The 4 still remains on the outside, and inside is a 5, and the 5 is now going to get squared. We square the 5 before we multiply by the 4 because exponents come before multiplication. 5 squared is 25, and 25 times 4 in this case is 100. So you can see that that's what occurred there as I did those 3 sets. I don't know how to answer the question outside of that, but anything that's inside of parentheses, you follow order of operations within there, but you do this stuff inside the parentheses first. Then exponentiation, then multiplication. PEMDAS, or GEMS, or whichever thing you use there. So sorry, my nose got really itchy. I don't know what happened. Anyway, so hopefully that answers that question. I'm not sure, so I'll move to the next one. Other than knowing the standard form of an equation, can you tell whether an equation is linear or not? Yes, and that goes to kind of what I talked about in class with my class. So our book really wants to preach on standard form because the very next section after the one where they talk about linearity is on standard form. So I guess they really want to just make mention to it. The problem is they write everything in standard form as well. But standard form, of a linear equation looks like this. Ax plus by equals c. And the way the book talks about it is, hey, ax plus by equals c is the standard form of a linear equation where a and b both cannot be 0, or a, b, and c are real numbers. A and b cannot be 0 at the same time. And that's kind of it. So what I told my and so they said if your equation is in standard form, then the equation is linear, which is true. That doesn't mean if it's not in standard form that it's not linear, but it means if you can't rewrite it in standard form properly like this, then it can't be linear. So the real questions weren't what is standard form all about, is what is in linearity that standard form contains that we can discuss. And the criteria that we want to look at are, number one, at least x or y does exist, that you do have an existing variable to vary things to then create a line. And as one or both exist here, the following qualifications also must occur. That the x and y terms are separated. And what I mean by that is there's no term that has both x and y in it at the same time in any such way. I can't have something that says 2xy or 2x divided by y, and I'll get more in the division in a moment here. I can't have anything like that. They have to be separate terms here. You can have a constant. Get away from me. It's a mosquito. Ah! Yeah, I didn't kill it. You can have a constant term and things like that. Just make sure the x and y terms don't have a x and y together. The third thing is the variables must be of degree 1. So variables of degree 1. Degree, another word for degree kind of for us is exponent. When you see an x, that means x to the first power. When you see a y, that means y to the first power. If it says another number, then clearly it's not to the first power. This variable is of degree 2. And the term is as well. Therefore, this would not qualify as linear here. But as long as you don't see whatever power it is, that means it's first power, and that means you're good. And the last thing here is your variables must be in the numerator. X and y in the numerator. Okay. And really, it should just be x and y. You shouldn't also have a z, because otherwise you'll be making planes, not lines. So these are the criteria for linearity. And that means, you don't need to be in standard form, but standard form tells you that much. Now, when I say variables in the numerator, there is a way for variables to be in the denominator and for it to still be linear if you can rewrite it in standard form and make it so. I think by and large you are not going to see many examples with that. I could give exceptions, but they're not going to trick you on that kind of thing. So if you're dividing by variables, if they're in the denominator, if I have divided by x, you're probably looking at what's called a rational function, and that's totally not linear. It will not graph and make a line. So there are other forms you can see, and a popular one we're going to be talking about is called slope-intercept form that looks like y equals mx plus b, and it's just a rewrite of this form where y gets by itself. Now, when y gets by itself, you'll notice here that this still follows all the properties that we have. At least x or y does exist, check. The terms are separated, meaning they're not together in a term, check. The variables are each of degree 1, they're to the first power, check, and they're in the numerator, check. So slope-intercept form's still good. There are a lot of different forms, even forms without names that are still good. As long as you have these 4 things here, by and large, you're probably looking at a linear equation. So no, it doesn't have to be in standard form, but yes, you should be able to rewrite it in standard form if it is linear. That doesn't mean you have to do that, but you can, and then that's enough for them. Okay, so good. There's that question down. And the next question is, how can you tell if a problem is in standard form? So just going back to this last one here to show you just the handwritten thing. This is when it's in standard form. X and y are on the same side of the equation, even though they're in separate terms. They're on the same side of the equation, and you have a constant term on the other side of the equation. Now remember, a, b, and c will be actual numbers. This could be 2x minus 3y equals 17. All right, there'll be actual numbers here. But you make sure that it is actual standard form of a linear equation for the same reasons, separated terms, degree of 1 in the numerator. But this is the standard form here. There are other things to standard form that actually come into play, such as a, b, and c really shouldn't be fractions. I know the book doesn't really talk about that, but they shouldn't be fractions. A should always be a positive number. They do weird things like that in standard form that I'm privy to, and I actually do use and talk about when we exercise it. But as long as you have the x and y terms on one side of the equation, the constant term on the other side of the equation, and it's linear, then you're in standard form. And these are the things that we express as linearity right here. So it's a good question. Just that formula kind of provides it there. We haven't done rewrites in standard form, as in let's get it in standard form, and I don't think that's something that you'll be asked to actually do in the class, in the curriculum this year. All right, let's get another set of questions. How can I get my grade up? Well, not content-based. You're not going to get credit for asking this question, that's for sure. You can ask me that at any time, and the answer's simple. You got to perform well. That doesn't mean it's easy to do, but it's a simple answer. The tests are worth 70% of the class. Homeworks are worth 20%. Quizzes are worth 10%. Now, tests are the big ones. So that's not saying sacrifice not doing homework to make sure you do well on a test. They are they're not mutually exclusive, or whatever. Doing homework should help you going into a test. You can ask questions to, things like that. I would say one way to certainly start is to start engaging in the conversations. Raise your hand in class and try things. See how you're doing with that. I'd say visit office hours. I'd say look at solution guide videos that I create. Look at this Q&A video outside of this question. The poor grade sometimes is a lack of effort, but a lot of times also is a lack of understanding, which could be from lack of effort by not trying to take notes, by leaving the computer after you sign in or something. And I don't know who asked this question. I have no idea. But this is just speaking to what I've definitely seen in that stuff. So I'm not going to get deep on that. You know how to get it. So, the grade is a score. Score is based on how you perform in certain things. Tests are scored on correctness. Homework's based on completion and attempting to do the homework and going over it with Mr. Robinson or somebody else is going to be very helpful for you. So I hope that does answer that. Sorry about that. You won't get credit for asking that question, though, because it's not content-based. All right, what is the easiest way to know if the equaction, to know if the equation is linear? I'm just going to go back to this thing right here, just kind of as people asked here before. These are the 4 criteria. The big one to really look at is the degree 1. If these are to the first power, if these are not to the first power, you know automatically that that's it. And this is one to really easily see, because when you see an exponent, it's that little number, like a 3 or something, that gives it away. So you can tell if one's linear or not based on this one really fast here, but you still got to make sure you're looking at the other ones. Obviously, if there's a fraction, make sure you're not dividing by a variable. These are the 4 things here. And really, the first one is just a default. It's going to happen. You're not just going to have an equation that says 0 equals 2, right? That looks kind of weird. So you are going to have this one kind of checked off all the time, or so it seems. You have to make sure that there's no third variable here, like a z, though, I guess. So that's true. Separate terms, degree 1, variables in the numerator. This is your checklist, because I covered in the last couple ones. I think that'll be enough for me on that one. There might be more questions like that because they're submitting their questions without knowing what other people are asking. But you do know what was asked in the last 2 weeks video. So on sequences, it's coming back. Hang on. I'm going to kill this thing. It flies to get out of here, guy. It's going to bite me in my sleep. All right. I don't know what I was talking about. I have no idea what I was talking about. All right. I'm going to move on. When does the add and subtract come into play? Excuse me. When does the add and subtract property come into play when solving linear functions? I guess they're talking about the addition and subtraction property of equality. Hang on. I'm going to keep that linear stuff off to the side because it looks like I might use it again. So, okay, let's take a look. So what we've been kind of doing here is there have been equations written in standard form. So let's say I have an equation that says 2x minus 5y equals 10. And I'll make it a little more difficult so that way it helps you to have a more difficult problem like this. The reason we might do something with this equation, even though it's linear, is we might be getting y by itself to get in slope-intercept form. You might not know how to graph out a slope-intercept form in a shorthand way yet, but you do know how to using a table. And it's better to get a variable by itself to treat as the dependent variable, so we can plug values into the independent variable and just compute along the way. Now, what are we going to do to get y by itself is we're going to be using properties of equality, not just the addition or subtraction one, but also possibly the multiplication and division ones. To get y by itself, we have to apply inverse operations to whatever is being affected by y. Y is being multiplied by -5. Eventually, I'm going to have to divide both sides by -5. This whole term is being added, the negative term is being added with a 2x. A 2x is adding with this term here that's negative. So I will be subtracting the 2x over. So this is a subtraction property of equality, or you subtract 2x to both sides. This is a place where you would do it to try and get y by itself. So negative 5y still exists over here. And if you're going to get your mx plus b form right here, this isn't truly mx plus b, but you need the x term first and then the constant term second. Just for familiarity's sake, you're going to see it a whole lot. I'm going to divide everything by negative 5 right here because, again, negative 5 is multiplying with y. So now I just use the division property of equality right there. So negative divided by negative is a positive, 2 over 5, x, and then positive divided by negative is a negative, 10 divided by 5 is negative 2. So I get y equals 2/5 x minus 2. Now this equation can be used to substitute values in for x, probably something that's a multiple of 5, so you can divide it by 5. Get values out for y and plot them in your graph. So when does it come into play? When you're trying to get a variable by itself, especially if you're trying to get it in slope-intercept form, especially if it's in standard form. It generally just takes 2 steps by moving the x term over and then dividing by the coefficient in front of y. Sometimes it's 1 step if there's nothing in front of y, things like that. Not too much in play, but that's when it comes into play. Thank you for asking. I hope that I answered there. All right, I do not understand problem 18 on page 108 for the homework. I can't take a question like that because I don't know what question you're talking about. I have no idea. That's specifically what you can't do. Oh, okay, to satisfy you on this one, I'll look it up because I don't know. This is math 1, right? I have a textbook. 1 second. Okay. There are a couple reasons I don't take these kinds of questions. Number 1, I probably have a solution guide video up on my YouTube channel. Number 2, you're not exercising any academic vocabulary or any knowledge of understanding to me to even give some words, because what if it's about sequences? I don't understand how to apply function notation to whatever. That way I can more generally do it, because right now all I'm going to do is I'm going to be answering a question to a problem, but I won't necessarily be resolving your problem that you have with it. Okay, I don't see a question 18 on page 108. I see a question 5 and a question 6. So if you're talking about from this is section 3.1. This is old too. So you're asking about something. Oh, this isn't even out of a homework thing. So I don't know what question's being asked. I'm sorry. I just wasted time for that. I'm not apologizing. I'm apologizing to everyone else watching. I don't know what question that was, but it sure wasn't for any of my stuff. So whatever you were asking, I'm sorry. You can't ask questions like that though. Not for credit. When you plug in a number in a sequence, like 8 for example, when you plug in the reciprocal, negative 8, that's not a reciprocal by the way, can you just do the other reciprocal of the other number? Example 8, negative 2, negative 8, positive 2. So this is about last chapter. Well, with the question you're asking, the answer is no. Let me get into what I think you're trying to put into play here. There's one big reason why it's no, and then there's another one that's like, well, there's also that. When you plug a number in a sequence, now let's say and I want it to make sure that it does what you get. So 8, negative 2. So I want something where I can plug in 8 into it, and I'll get negative 2 out. Let's see. How about f of n equals negative 2n plus 14. Okay. So f of n equals negative 2n plus 14. So now you're saying, okay, if I plug if I plug 8 into here I'll get negative 16 plus 14, which is negative 2. Now, remember what this means when I substituted an 8 in here. That means the 8th term of the list is negative 2. So there's a first term, in fact, first term, second term, third term, fourth term, fifth term, sixth term, seventh term, eighth term was negative 2. Ninth term, 10th term, etc. Okay, so that's what we just found in the sequence, and I assume that's kind of what you're asking here. Okay, now a couple things to address on yours why this is not the case. Well, number 1, the term's not called a reciprocal. I guess we'd call it its opposite. You could say inverse. You could say additive inverse. I know that's kind of weird, but you could do its inverse. Reciprocal of 8 is 1 over 8. Okay, that's a reciprocal there. Number 2, and this is kind of a picky thing, but you're talking about plugging in negative 8 into this thing. You specifically mentioned the word sequence, and the thing is, sequences do not have negative term positions. They have negative values. That's fine. You can have a negative value. You can't have a negative term position, meaning you can't have a negative eighth term. You start at term 1 and you go to term 2, etc. So there is no term negative 8. Now, if this were linear equations like the thing we're in, and then you're asking in that situation, if I have a table in an equation, let's say you could plug in any n value that you wanted, or let's say it said f of x. Let's change it. Let's not talk about sequences anymore. Now let's just talk about f of x. If I'm talking about f of x here, could I just plug negative 8 in here, and would it give me the opposite of the answer that I have? That answer is no. There's a chance it could. Not in this. See, this is going to be positive 16 plus 14, and that's going to be 30. So you have one point that's 8, negative 2. You have another point that's negative 8, comma 30. So I just disproved it by example. That's not going to happen. Now, the only way that that will possibly happen is if you have a linear equation that passes through the origin. So let's say I have this little graph guy right here, and I have some sort of graph, some sort of line here that does something like this. It passes through the origin. Actually, I'm going to do it the way that you'd want me to. 8, 2, negative 8, 2, whatever. So look at this line that I'm going to do that's passing specifically through 8. No, wait, hang on. You want 8, negative 2. That's passing specifically through 8, negative 2 and negative 8, positive 2. Okay. Here is mosquito thing. Get away. Move. Why do you fly by me? You know I don't want you. Here is 8, negative 2. Here is negative 8, positive 2. Where else did it specifically cross? The origin. The only way to do this is through what's called direct proportionality. And within that mindset, you'll get the inverses within there. If it crosses anywhere else that's not the origin, you will never get that. Even if I go just a little bit higher up like there, it'll never get that. It won't cross through the origin anymore. And therefore, it will not cross through that other thing. Sorry, I'm messing it up now. But you get what I'm saying with that. So, no, you can't apply it. And especially not for sequences, for the reason I told you there. All right, let's keep moving on here. 1. A pool is filled with 500 gallons of water. Well, this is an example. Each minute after that, 50 gallons are poured into the pool. Write a function. Are you testing me? Write a function in terms of W of t that represents the situation. You're not getting credit for this. This is you're not asking me what I'm not sure what you're asking. I know what you're asking me. I don't know what you want out of this besides this answer. Write a function in terms of W of t. Okay, so W of t equals, what does it say? A pool is filled with 500 gallons of water. Each minute after that, 50 gallons are poured into the pool. So T is representing time in minutes. W is representing gallons of water. 500 of gallons of water are in the pool, and we're going to add 50 every minute for T minutes right here. There's the function that represents that. There's your answer. This looks familiar. Okay, this was on our practice test. So once again, it's one of those things where, again, whoever asked this, students, you're not getting credit for this. This was on the practice test, so there's a solution guide on there. Now I'm like, when I wrote this out, I'm like, I've done this before. Yeah, totally. And if you were going to ask how to write word problems, that was asked in the last video as well, by the way. How to write equations for word problems. All right, the next question. How far forward do you take missing assignments before they just become zeros? Not a content-based question, but I'll answer it. Let's say we were physically in the classroom. Let's say COVID wasn't a thing, ever. And we were physically in the classroom, all of us. What I would generally say is, I like to deduct half a point off an assignment all the way until up to half credit, and you can receive up to half credit by the end of the unit. After the end of the unit, the assignments would become zeros. So if we're in Unit 3 right now, you can turn in anything for Unit 3 during this unit. You'll have some late penalties, but you can turn in anything at any time for Unit 3. You cannot turn in anything from Unit 2. Once Unit 3 finishes, you cannot turn in anything for Unit 3. So those would become zeros at that point. Think about a couple reasons why. Number one, I want you to focus on your current unit and your current classes and such, and you had the whole unit to work on it. Number two, that's not our focus of our content anymore. because, we're on a different unit now. So I want you to really, not only do I want you to do the homework on this current unit that we're on, but I want you to focus on that unit and the material there. And number 3, students who make it up often have means of making it up that aren't really legitimate. They found answers online, they copied their friends' homework, something like that. They rush through things for credit and not for learning. The homework is meant for learning, and credit is a way of holding you accountable of that. But if it's something we've already learned in the past and it's something you're just going to rush through anyway, it's something I wouldn't want to do. That being said, I like to carry that kind of mantra through distance learning. However, there are so many other hiccups in distance learning, including students that aren't as engaged or students that need that wake-up call. This is the first time you're doing this, that it's a little bit harder for them to come through with it. And if come November, it is November, but if come like this month right now, students are finally realizing that they need to catch ground, make up work, I will give them credit for the old stuff, but I'm still going to keep those other things in mind. You can't just copy someone else's work or an answer out of the back of the book or something like that. You want to do that, and I want you to focus on the current unit stuff. If you can show me at this point that you're doing a lot better with your work, then we can find ways to excuse the old work just as a remedy for yourself to say there's still a chance for you to pass. But in general, by the end of a unit, I'd want to call it a 0 from then. There are special circumstances, but just keep that in mind. Okay. Thank you for asking. No credit for the question. It's not content-based. All right, next question is, what is the difference between the two rules f of n equals f of 1 plus d times n minus 1 and a sub n equals, so they're going to do, I'll write it out, a sub n equals a sub 1 plus d times n minus 1. So there is no difference, meaning they achieve the exact same goal. They're just written differently. So f of n equals f of 1. I kind of have hiccups here. I think I'm going to hiccup a couple times. Plus d times n minus 1. This is what's called function notation. It's not, this is a specific rule, but the way that this rule is written this time is using function notation. This one down here, a sub n equals a sub 1 plus d times n minus 1. This is what's called subscript notation. Notation, for all intents and purposes, just means the subscription. For all intents and purposes, just means the way that something is written. So the way that this is written uses subscripts. The way that this is written uses functions, function bases. So there's nothing different. When I ask you to find f of 7, that's the same thing as finding a sub 7. It's the way that's written. Why are they written different ways? Because over the course of math, there were different times that people discovered how to write different things to make sense of showing different versions of a variable in some sort of way. There's not much difference between these things other than just the way that they look. You'll see subscripts used a lot more in physics formulas for different reasons. And in formulas in general, you'll actually tend to see subscripts a lot more than you'll see f of, things like this, because this can get clouded with, look, this isn't multiplication, but this is, so it can get a little confusing there. But this is used a little better for calculus when you're doing derivatives and with inverses and stuff. There are just other uses for these that are applied, but the same result comes out. This is the explicit rule for an arithmetic sequence either way. You want to just be comfortable in understanding that they both get you the same thing. And that was a good question, but that is the answer. They're the same. All right, not number 16. Cell 16 here. The 15th question asked is, how do I graph a linear function? I'm not going to get too deep into the whole thing because it would take a while, but keep in mind, you are going to learn in next module, you are going to learn how to graph in a shorthand way, meaning without a table, out of slope-intercept form. In y equals mx plus b, you will have a very nice conventional means of being able to graph the thing without ever needing to calculate anything, just really quick counting things. And even with a fraction as your slope, you'll feel really comfortable with it. You'll even embrace and love having a slope for it, believe it or not. The current way we're graphing a linear function is by hopefully getting it in slope-intercept form, y equals mx plus b. Let me get this out of the way. Y equals mx plus b, and then choosing values for x to get values out for y. So in u of y equals mx plus b, we create a table, we pick values for x, we plug them into the equation, we get values out for y, whatever they are. I like to do some negative, some positive, and 0. This is a good set if your graph is centered. If there are no fractions on your slope, this is a good set and you can get values out. Whatever those values are, the mosquito thingy. Whatever those values are, you plot them as points on a graph. So let's say this was negative 2 comma 7, or let's say that you plug negative 2 out comes 7. That means negative 2. I'm going to get something to swat this thing. My hat. I see it, but it's nowhere near me. I'm going to get negative 2 comma 7 as a point to plot. Let's say this was negative 1 comma 5. I'm going to plot that point. So you plot these points here, and they should follow a line. This one in particular follows a line. I do know what the actual equation is, but I'm just going to ignore it. This is 1 comma 1, and let's say this was 2 comma negative 1, like that. Right? Then you plot those points, and they should appear to be linear, unlike this set, and then you draw the line through them. So that's how you graph it, at least the way that we are currently set up for it. Get it in slope-intercept form by getting y by itself, using a couple steps that I answered earlier. I forget which equation it was. And then, or which question it was. Construct a table where you can get some points in, plug in the points, get values out, plot them, connect them. Draw a line. This is very roughly drawn. But that is how you do it. Like I said, you'll learn a tableless graphing method in the next module, but first I want to make sure you know how to just even get the nitty-gritty done. It's not just here it is and go. You want to accept the fact that that's how those things work to begin with. All right, thank you for the question, though. Okay, do you always use x minus 1 when solving for the term in arithmetic sequences? We used n minus 1, and I just had that formula up before, so let me pull that one up again. Do we always use n minus 1? There's a way to get it started beforehand. We haven't talked about it because the math department decided we wanted to do it in this way to practice distribution, combining like terms. So do we always use n minus 1 here? In an arithmetic sequence in this raw form, yeah. Now we would distribute. I would likely distribute and combine like terms to simplify what's there. But yeah, there's another version that uses what's called f of 0. It's a theoretical zeroth term, which doesn't really exist, which doesn't use n minus 1. The formula's logic, again, was answered in my previous Q&A video, so if you want to look to that and see, you can. I think it's the last question on there. What's the, where does the form come from? Why is the formula what it is? Sorry, I'm looking at this mosquito. Let's see if I can get it. Well, I whacked it. I don't know if I killed it. Got it with my hat. It's probably inside my hat now. Probably on the ground. Can it bite when it's dead? I do not know. Anyway, so, yeah. Are you always going to use it? Yeah. Yeah and no. For this formula, yes. Because the formula exists for a very certain reason that I've already mentioned before. So, yep. How can you tell an equation is or is not linear if you haven't graphed it? Well, that goes. So that question's been answered. So we look at the equation. We look at the equation and we look at the criteria. So let me move this back out of the way. And good thing I saved this other set. I'm going to remember to do that from here on out. So this other set's right here. Even if you don't graph it, you can look at the equation and ask yourself a few things. One, you could ask, is it in standard form? But it's not about whether or not it's in standard form. It's what does standard form tell us about linearity? And it asks these questions here. Do you have existing variables, 2 or 1? If it's yes, keep moving on. Are the terms separated? Once again, no x, y joining together. Are the variables of degree 1? Do they have an exponent of 1 that we can't see because they don't write a 1 if it is a 1? If it's another number, they write it. And are the variables in the numerator? Are we not dividing by variables? That's how you can tell. Those are the 4 steps. It doesn't have to be in standard form. It could be in slope-intercept form, like we've done before. It could be in any unknown and unnamed form. But without graphing it, as long as you can get to this checklist each time, then I think you can trust that it's linear. I'm trying to think of any other things that would kind of make it so. I know I'm being a little general with some of them, like variables in the numerator, because you can have them in the denominator and still rewrite it in standard form if the equation allows it. But a lot of them just won't. Okay, is this the right order? Is what the right order? Oh, this might have to do with this question here. Is this the right order? PEMDAS, P-E-M-D-A-S. Yes, yes. Please excuse my dear Aunt Sally. This is called a mnemonic device. A mnemonic device is a way of remembering something with something else that may be completely unrelated. My Math 2 students know about something called the FOIL method for distributing binomials. Please excuse my dear Aunt Sally is a sentence for you to remember the phrase PEMDAS, I guess, the acronym, which PEMDAS isn't a real word, but standing for parentheses, exponents, multiplication, division, addition, subtraction. It is your order of operations. And I think the very first question on this Q&A Power Hour had to do with, I forget what's the first question, but it had to do with order of operations in and of itself. So actually just looking at that though, there's one thing that some students actually don't get right, and it's that multiplication does not come before division and addition does not come before subtraction. So while it's true that parentheses do come before exponents, and while exponents do come before multiplication, multiplication and division are actually on the same tier together, and addition and subtraction are on the same tier together. So there are really 4 tiers of values in order of operations. It's 1, 2, 3, and 4. That means if you have a left to right addition subtraction like this, if you have 7 minus 2 plus 9, I don't do 2 plus 9 first and then do 7 minus that thing. Not unless there were parentheses around the 2 plus 9. So not unless you had this going on, right? So in that case, yeah, you do addition first. Now you can do negative 2 plus 9 first. That's your prerogative, but understanding that now that's kind of 7 plus negative 2 plus 9. So it's no longer subtraction anymore if you make the 2 negative. You do subtract first. 7 minus 2 is 5. 5 plus 9 is 14. That's the answer. So subtraction doesn't come after addition. They're on the same level. So you just go left to right once you have only things of that tier. All right. That's why some teachers or some books and whatever now use what's called gems for several reasons. This is grouping. And while this is exponents, this is multiplication and division. This is subtraction and addition. It's a real word now. It shows you these on the same tier. And grouping isn't just parentheses. There are also square brackets. There's also square root functions. There's also absolute values. Heck, if I have something like this, 7 divided by 2 plus 9, we group in the denominator. I don't see parentheses. That doesn't mean you don't do that addition first. You do. So there are ways and reasons why people say grouping here. I grew up with PEMDAS. I remember doing this 1 extra credit project in 6th grade on PEMDAS. That was really fun. I made like a comic strip thing out of it. All that. Is that the right order? Yeah, that's the right order. And that's what all those things mean. Thank you for asking. I don't know if that really has much to do with our content currently, though. Okay, what can I do to get caught up on my grade? Well, if you have any zeros, look to see if there's anything you can make up then. Definitely look, any test you take, definitely take those test corrections to heart. That's going to help you learn the next material a little better and prep you. And when you take a practice test, when you get a practice test, take it first on your own and then refer to my solution guide video after and use that system that I've asked you to try and use before. Try the things that you do on your own in pencil. Correct things in pen, like use things that Mr. Robinson says in green pen, do things that you do as a correction of it in blue pen, things like that. So you are aware of what you know and what you don't know. Those are super duper important there. Still a lot of questions here, so I'm going to keep moving on. How do you know when to connect the plots on a graph? This was kind of a question on the last set, so I'll just tell you this for now. The majority of the time you will connect the dots on a graph because we're referring to what's called an all real numbers domain. Whenever I suggest points for you to plug in, or the book does, or whenever you plot points to plug in, that doesn't mean those are the only ones that exist. It's not just -2, -1, 0, 1, and 2, unless they specifically restrict your domain. Meaning, if they say the domain is -2, -1, 0, 1, and 2, that means those are the only x values that exist. That makes it a discrete function where you do not connect the dots. And in sequences, they are all discrete because there only is a first term and a second term and a third term. And there will be some word problems that say things like, I sold 1 bike and 2 bikes and 3 bikes for $70 each and blah, blah, blah. How much money do I make? And that's discrete because you can't sell half a bike, So if it's a word problem, the discrete versus continuous thing will dictate itself based on what you're talking about, whether they're items, whether it's a progressive flowing thing like time or something like that. But for the most part, you can assume continuous in other situations unless they restrict your domain or we're talking about sequences. But you know when to connect if you know it's continuous, and for the most part, they will be continuous. Our current module, I can't think of a time it's not going to be continuous. Always continuous, connect the dots, draw arrows. All right, the next question is, why is substitution so common? I don't know. I mean, it's because we have variables that we're solving for, so things have to take its place. Variables are unknowns. We use numbers to substitute for them. It's not common in other things that we don't use them. I don't know how to say it, but if you're not using something with variables, then we're probably not doing a lot of substitution there. I don't know. Substitution is just a part of... you're probably talking about because we're making tables right now. We're making tables and plugging things in to get values out for y. Trust me, we're going to do a lot less tables next module when you learn tableless graphing for linear equations. There's it. All right, next question. Can it be linear but still not in standard form? Yes, you have slope-intercept form, or just any other form. Remember, I'm going to go back to this little guy right here. As long as you get all of these things on the checklist, I'm not even going to put standard form here this time. I'm just going to show you the checklist. As long as you have these bullet points checked off, you probably have a linear equation. Standard form happens to check off all these bullet points, but so does slope-intercept form, and so does any other form that make sure it has all these checked off. Just make sure your variables are clean as daisies in their own terms. They are in the numerator, they are of degree 1, and they are not with another variable, and that they exist. And yes, it does not have to be in standard form. Now, keep in mind, and I keep saying this as well, more to my class than in this video, if it is linear, that means you can put it in standard form. That means it is standard formable. That doesn't necessarily mean it has to be in standard form to be linear. Just keep that in mind. I have problems learning math, and I don't get them in just one simple explaining. So, like, I need more explanations. Okay, I tend to think I give a lot of explanations and examples in class. I'm a big talker. You can tell in this video. It's gone 51 minutes. This is the Q&A power hour, after all. I understand that, and keep in mind, that's why when we do homework, we do a lot of practice, a lot of drill and kill and things. I make solution guide videos for those that help, and I do give examples in class, and I hope that when I call enough people to try in certain parts, hey, you plug in this number, you plug in this number, everyone's getting a shot. So I hope that you're not saying it in response to me maybe not giving enough examples, but if you feel I'm not, there are office hours, there's school-wide tutoring, there are ways that you can still get more examples. I acknowledge the fact that you might not still understand it after it's taught once. And I'm not saying you should understand it then, but I am saying that sometimes in class there's only so much time for so many things to do. And listen, I tend to think I do give a lot of examples. I don't know if I do or don't, but I tend to think I give a lot of examples. So if I don't give enough for you at that time, that's where you got to do a little more exploring, including looking at these videos here. I mean, look, sometimes it just takes a little more to study and practice. Not everyone gets everything the first time. It took me a lot longer to learn guitar than other people, or a lot less time, depending on who you are. So, just takes more or less depending on who you are. That's all I'm going to say there. And again, it's not a content-based question, so no credit on that one, but I'm glad to have answered it. What's the difference between linear and standard form on a graph? Well, we're assuming that standard form is standard form of a linear equation. There is standard form of a circle, standard form of a quadratic equation. They're all different equations there. Standard form of a linear equation is automatically linear. So there is no difference. If you're asking about slope-intercept form, there's no difference on the graph. The difference will be in the appearance of the equations. In slope-intercept form, what was the example I did earlier? I did something where I said it started off as 2x minus 5y equals 10. Here was standard form. And then here was y equals, I think it was 2/5 x minus 2 or something like that. These are two different representations of the same graph. That means these both give you the same graph. This is standard form. This is slope-intercept form. They're both linear. They both make a line. Yeah, I don't really know what to say on that afterward. And I don't know if you were asking about slope-intercept form, but there's no difference between them. There's a difference between their appearance and their equations. And there's a difference in how these equations are helped using find something on your graph feature-wise. Slope-intercept form helps you find the slope and y-intercept. Standard form is a good way of finding both the x and y-intercept pretty quickly, even though it's not prevalent. It's not visible right here. Otherwise, they'd call it intercept form. But no, yeah, they're all linear. Standard form is linear, and the one that we're referring to there. And so, yeah, I'm not really sure what the question specifically is, and I hope I answered it there. But no difference on the graph there. They should all kind of give you the same graph. What information do you need to write a recursive rule for an arithmetic sequence that you do not need to write an explicit rule? You need the same things. I know we're not doing recursive rules together, just because. We're not doing recursive rules together, but in the recursive rule, you need to find two things. Your common difference and the value of your first term. In an explicit rule, you need to find two things: your common difference and the value of your first term. Now, what's different between an explicit and a recursive rule is an explicit rule is good for finding any term that you want imaginably. You can find the 100th term right off the bat, or the 1000th term right off the bat. You could find the 5th term right off the bat, but if you have the first 4 terms, finding the 5th term might be easier using recursive logic. And I only say that because I always want to talk about the rule. The logic behind the recursive rule just says you use the previous value to help you find the next value. So if I know that my common difference is 3, and I know my 4th term is 11, then instead of plugging 3 into some equation where I'm trying to get that 5th term, I can just do 11 plus 3 to figure out the 5th term. And then 14 plus 3 to figure out the 6th term. And 17 plus 3 to figure out the 7th term. So that's what recursive rule can help me do right there. Now, what was the question here? What information do you need? You just need the common difference and the value of the first term. Both of those will help you get what you need there. So information is the same. The equation is different. The way you use them and the strategies and benefits are different as well. Okay, the next question. Let's see. We have 3 more. Why are we not being taught the recursive rule? Okay, recursive rule this year. Is it not necessary? Because looking at my cousin's sophomore homework when I went over, it looks like maybe it could be useful. Well, I'll tell you what, the recursive rule as an equation is probably not very useful in and of itself. There is something to be said of it and to look at with the f of n minus 1 bit. I'm not going to write out the rule because I don't want to bog people down with it. The rule, like I taught the rule last year. I've taught it in other math classes before. The rule can confuse people more than it can help them because they look at other things that they thought were multiplication before and now is function notation, and they're just confused by what the rule is asking them to do. The logic, like I just said before, is completely fair. It's something that all of us look to do. I'm going to go back to my classic one. In fact, the one that I just mentioned probably was kind of it here. I'll go back to my classic rule I've been using here, or my sequence I've been using here, 2, 5, 8, 11. If I asked you what the next term in the sequence was, you would find it by recognizing a pattern from one term to the next, adding 3, and then you would add 3 from the previous term to get to the next term, and you'd get 14. What you just used is what's called recursive logic. Recursive logic says find the value of the next term by taking the value of the term before it and doing something to it. That's what recursion is, kind of iterating through this loop of taking the previous thing to get the next thing, the previous thing to get the next thing. You don't do something like, well, if I start from the number 2, I'm going to add 3 one less time than the position that I'm looking for, and I'll get 2 plus 3 times 4, which is 2 plus 12, which is 14. You don't do that in your head. Oh, 12, which is 14. You don't do that in your head like that. This helps you. The explicit rule probably wouldn't help as much to find the 5th term as recursive logic would. Because this really just helped me here. Finding the 100th term, I wouldn't want to add 3 over and over and over and count up to 100 till I get it. I would just plug 100 into here to help me out there. Oh my god, it's still alive. It just freaked me out. How did you not die? And where did you just go? I hope this thing gets caught on camera. I hope it doesn't get caught on camera. Then it makes me look like I'm freaking out here. Hang on, let me try and take care of this thing. Let me pause this video 1 quick second here. Okay, well, I couldn't quite get it there, but anyway. So the recursive rule, look, it's something that for time's sake, I guess we didn't cover it. For confusion's sake, I guess we didn't quite cover it. Most people are probably going to be happy over the result that we didn't. So I hope you'll be happy with that as well. All right, 2 more questions here. What is the difference between the f of x equation and the a sub 1 equation? So I answered that one earlier. You can find the question. You'll see it up there. There is no difference. One's called function notation. One's called subscript notation. Different appearance, same results as you do things. They're used in different cases. I don't want to answer it again. They're used in different cases for different things, but they are interchangeable. And the last question is, if a function changes over time by a few numbers, like temperature, but not drastically, then is it still considered continuous? Yeah, continuous doesn't have to do with how drastic something changes or not. It has to do... see, I think some people think continuous like the word continual. Continual kind of means, like everlasting, continuing on and on, even from the point that you're looking at. Continuous just means, this progressive occurrence of something within a set. So if something continuously occurs, if something continually occurs, it probably goes on forever. If something continuously occurs, it means there's this stream, this thread from one set to the other that you can follow and track. And it doesn't matter to your question. It doesn't matter how drastically that thing changes. It can go up and down a lot, or it can just stay flat, right? But it's still continuous because there's no separation between your points. Like, it's not a point and jump to get another point and jump to get another point, like there are gaps. So in temperature, or whatever, it's still continuous, yeah, because all it's saying is that at any given time, at any second, I can have that temperature recorded. And all day it might be 70 degrees. All day in your room might be a flat 70 degrees, but it's continuously 70 like that. It's a continuous, at every second it is, or it goes up to 71, and it rises up to that point. It doesn't just 71 like that. So kind of keep that idea in mind when it comes to continuous versus discrete. It doesn't have to do with how drastic it is, just can you measure it at any point in time, really. All right, so that'll do it for this one, guys. This is Q&A Power Hour here, and that was an hour long, so I do hope that that was very helpful and useful for you guys. Thank you for watching, and I'll see you guys in a couple weeks. Take care. Bye.